All right, good morning, guys. Today's lesson is going to be about convergent boundaries. And convergent boundaries are where two tectonic plates are colliding or moving towards one another. We can break these boundaries down into three different categories depending on what types of crust are colliding. We're going to spend some time talking about what happens when two continental crust plates collide. We're going to talk about what happens when two oceanic plates collide. And then we're going to talk about what happens when a continent and an ocean plate collide. Okay, so a lot of the things are similar, but there are some very unique landforms that are created during this process that you need to make sure that you understand. Okay, so the first one we want to look at is continent versus continent. All right, so the two types of crust are the same. Generally speaking, one crust may be younger or older than the other one, and usually it is the older crust that will do what we call subduction or move underneath the other. But sometimes, if the densities of the two crusts are the same, there really won't be any subduction or one crust going under another one. They'll just kind of wrinkle up. And the best way to explain that is if you were to take a towel and fold it in half and lay it on your table, and then put two hands on either side and push the towel together, the towel will wrinkle up and fold up in the middle, creating what likely would be a mountain range. And that's generally the landform that we're talking about creating in a continental collision. So here you can see in this video, there are some folds. Okay, so you see these, how this crust here, different colors, right, and then they fold up. So this would be very similar to how that towel would fold up as well. And normally when we think of rock, we think of this thing that's super rigid and hard and would break under these kinds of pressures. But because this is happening so slow, because there's a little bit of heat involved, there's some plasticity or flexibility in the rocks. And so we get these folding marks or folding lines inside the mountain. Okay. Here as an example of how the Himalayan mountains, the tallest mountain range in the world, was created, again, by continental collision. We have of course, the Indian plate and the Asian plate colliding to create these mountains here. Okay. Okay. So what are the effects of the motion? So again, plates fold into one another, creating folded mountain ranges. Earthquakes, of course, will occur when anytime plates collide. They will cause the earth to quake or shake or break. But there is usually no volcanic activity. And the reason for that is usually there is not that much subduction going on. And so you rarely find volcanic activity. So there are no volcanoes in the Himalayan mountains. There are no volcanoes in the Appalachian Mountains, which are here in the United States. Okay, so the landforms, remember, this is the focus of 8th grade here, is the landforms. So the landforms that form are, of course, folded mountains, like you saw in the diagram before. And some examples of that, of course, the Himalayan mountains in Asia, and then the Appalachian Mountains in America. So when we talk about looking at those two mountain ranges and compare them, the one on the left is the Himalayas, and the one on the right is the Appalachians. And you can tell right away that the Appalachian Mountains on the right are much lower and smoother than the jagged peaks of the Himalayas. And excuse me. The reason for this is due to the age. The Appalachian Mountains are extremely old compared to the Himalayas. You'll notice there's no trees growing on top of the Himalayas because they're too tall. Trees cannot be supported that high in the atmosphere, but the Appalachian Mountains are pretty covered entirely by trees because the height of those mountains are low enough to be under what we call the timberline. So weathering and erosion have worn the Appalachians down and reduced their size. In another couple 100 million years or billion years or however long, the Appalachian Mountains will completely disappear. And that happens because of weathering and erosion. However, the Himalayas, because they are much younger, are still rising due to the collision between India and Asia. So just because they've collided doesn't mean that they're still not pushing towards each other, which is still causing the Himalayan mountains to rise. One interesting fact, though, is that the fossils that are found at the top of the Himalayan mountains are those of sea creatures, suggesting that the crust that used to make up the mountains used to be underwater millions and millions of years ago. So that, in a nutshell, is continent versus continent. Again, the landforms, the most important piece there are folded mountains. Okay, so let's talk a little bit about convergent versus ocean. All right. So as I kind of play this video, it kind of moves a little bit slowly. So we see here, this is an island arc that exists in the Caribbean. The Virgin Islands are here. This is South America. So Grenada, St. Vincent, St. Lucia, Martinique, Dominica, Guadeloupe, Montserrat, St. Kitts. These are all very big tourist destinations. And these were created because two oceanic plates were colliding. So if you see here in the diagram as it plays, you can see that one plate is subducting underneath another one, which is due to the older crust. The older crust is the one that is doing the subduction. So going down, and then as that crust gets lower into the mantle, it will melt. And when it melts, things become less dense and they rise. And then we see these little volcanoes pop up out of the water. And then as I play this again, you'll also notice that this isn't the only one. There's another one that'll pop up, and another one that'll pop up, and another one that'll pop up. And so this kind of plate motion, when two oceanic plates collide, is how these island arcs are built. Okay, so you'll see here, again, the example of the island arc in the Caribbean Ocean, which is very close here to the United States. Okay. All right. So what are the effects of the motion? Of course, subduction occurs. One plate is always going to go underneath, and it's usually when, again, the plates are the same oceanic. It's usually the older, more dense plate that is subducted underneath, whereas the lighter or less dense plate, younger, less dense plate, tends to ride over the top. This is the place where the crust is recycled. So the hard crust, which originated millions of years ago, was created when magma rose and froze on the surface of the earth. And so this is the part where that crust is actually diving back down into the mantle and melting and becoming magma again. And so that's why we say crust is being recycled. Of course, again, effects would be volcanoes and earthquakes. Anytime two plates are rubbing up against one another like that, we are going to get some earthquakes. You're going to see earthquakes at every single type of boundary as we go through these this week. So the landforms, again, this is the important part of 8th grade, are ocean trenches and island arcs. And I'll show you some examples of the trenches here in just a second, but we already saw the island arc. And examples, of course, are the Marianas Trench, which is out in the Pacific Ocean, and the Aleutian Island Arc that is in Alaska. So this is the Marianas Islands. The Marianas Trench is created right here. So this is a very deep place, and we'll show some more images here in just a minute of what a trench looks like. But again, these are the another island arc that's created by the Pacific Plate and the Eurasian Plate colliding. Guam is a United States territory. There's an Air Force base located there, but you can see this long arc of islands that have been created by that motion. Another example, again, is the Alaskan islands, the Aleutians that come off of the main body of Alaska. And you'll see here all of these red triangles here are volcanic. So volcanoes, all of these islands here also are volcanic in nature. And so these are all the volcanoes that are in Alaska, not all of them, but a majority of them. and how each one of these islands was created because of the volcano and the collision of two oceanic plates here and here. So just a fun fact, I grew up in Alaska. Well, I didn't grow up in Alaska, but I did spend 3 years there. And I remember I lived in Anchorage, Alaska, right here. And I remember one morning getting up and seeing that the snow had turned black. And the reason for that is because Mount Iliamna right here, which is actually the name of my sister's elementary school, had erupted and had sprayed some of the black ash from the volcano had fallen onto Anchorage and turned all of our snow for a couple of days completely black. Okay? So let's talk mainly about ocean trenches. So again, a trench is formed because of subduction. Again, we see subduction here is this plate moving underneath another one. The magma, the plate itself then melts, and then the magma rises on the other plate to create volcanoes on the other side. There is pressure between these two plates, so there is some distortion that takes place that creates some mountain ranges here. But this little V section right here is called the Marianas, or an ocean trench. Again, you can kind of see it from a different angle here. There's a trench that forms right here, so this crust actually dives down and then comes back up as we get to the actual continent. So the deepest trench, the deepest place in the ocean is the Marianas Trench. It's about 9 miles deep. You can actually take Mount Everest, flip it upside down, and fit it inside of the trench right here. And yesterday we talked about the 2011 Japan earthquake, and this is exactly the process that's going on that created that earthquake. All right, and so to finish up, let's talk about what happens when a continent and an ocean collide. So it's really kind of the same thing as when two ocean plates collide, except that the volcanoes are created on land and not in the middle of the ocean. So we still get trench formation right here as this plate subducts underneath the other. And then we get this line of volcanoes that form on the coastline. And so this is a map of the Pacific Northwest of the United States. So this is California down here, Oregon, Washington, and this is Canada. And you can see each one of these red triangles that forms along this line here is a volcano, not necessarily active at this moment, but still a volcano. This one here is Mount St. Helens. It's very hard to read. This is the volcano that erupted here in the United States back in 1980. Mount Rainier is right here. This is Seattle in this general area right here. So Seattle is under a little bit of danger from Mount Rainier possibly erupting in the future. So again, Mount Lassen, Mount Shasta in California, Crater Lake, Newberry Volcano, Three Sisters, Mount Jefferson, Mount Hood are in Oregon, Mount Adams, Mount St. Helens, Mount Rainier, Glacier Peak, and Mount Baker are in the state of Washington. So again, the effects of the motion, there's still subduction of the oceanic crust underneath the continental crust because of the density. Oceanic crust will sink into the mantle, and then that oceanic crust will then melt and then rise up through the continental crust, creating volcanic mountains. And of course, we also have earthquakes as these two plates are rubbing up against one another. The landforms that are created here, again, this is the focus in 8th grade, are again trenches. We have volcanic mountains, subduction zones, and the examples are the Cascade Mountain Range, Mount St. Helens here in the United States, and the Andes Mountains on the west coast of South America. So this is kind of a diagram of how the Andes Mountains of South America form. Again, we still have some compression. We have oceanic crust that is subducting, and then we have magma that is then melting and then rising up through the Andes Mountains. And again, this is on the west coast of South America. And then again, this is kind of a clearer map of what is going on, and it's in French. I should have noticed that, but anyway, same concept of what's going on in the Pacific Northwest, California, Oregon, Washington. We have the Juan de Fuca plate that is subducting underneath the North American plate, creating this line of volcanic mountains called the Cascade Range. So when oceanic plates collide with continental plates, the denser oceanic plate is subducted underneath the less dense continental plate, And as the ocean crust dives deeper, it melts and rises up through the mountain to create volcanoes. All right, guys, hopefully this sums up everything that we'll discuss in Zoom today. Again, if you can't make Zoom today and you watch this video, please use this information in the notes attached in Schoology in order to complete today's activity. All right, guys, thanks. Y'all have a great day.